Hello, welcome to this Nanophotonics and Plasmonics course.
Which is a cross-listed course for undergraduate and graduate level. My name is Dr. Nicolas. I'm assistant professor at the University of Texas San Antonio in the Department of Physics and Astronomy. If you have any question throughout the course, you can email me at this email address, nicolas.large@utsa.edu. This course has been designed based on 3 textbooks, which are complementary. The first one, Principles of Nano-Optics by Lucas Novotny, covers the entire content of the semester. This is more a general introduction to those various topics we're going to be covering in nanophotonics. The second and third textbooks, Plasmonics, Fundamentals and Applications by Stephen Meyer, and Optical Properties of Metallic Nanoparticles by Andreas Strugler, cover principally plasmonic topics, which is going to be covered in the second half of the semester. You do not need to purchase those textbooks, they are not mandatory. In terms of assignments, the semester will be divided into 4 major assignments. So the first one will be a review article that you will have to read, understand, and you're going to have to prepare a presentation about this review article, explaining what you've extracted from there. So this review article is going to be on several topics on nanophotonics. I'm going to post a list of recommended review articles, but any review article on nanophotonics or plasmonics would be welcome. Soon after chapter 2, there's going to be some take-home problems, standard take-home problems, so they're going to be related to chapter 2. Further down the semester, you're going to have to read a more technical article, and similarly, you're going to have to read the article, prepare a presentation for the rest of the class, explaining what this article is about, and trying to make connections between the article and what we see in class. Finally, one of the big chunk of this course is comprised of an 8-week computational project, which is going to be the second half of the semester, where you're going to have to design a computational model, study some physical properties of a given physical system related to nanophotonics and plasmonics, and then you're going to have to prepare a presentation and a report summarizing your computational methodology, the physical problem you're studying, interpreting your results, and discussing this based on what you've seen in class. This is a breakdown of what are the topics that we're going to be covering in class this semester. So this is based on a 16-week semester. Week 1, that's what we do this week. After this course introduction, we're going to start discussing a quick historical survey about nanophotonics. We're going to deep dive into the theoretical foundations, which are just electrodynamics. We're going to review Maxwell's equations, go into the macroscopic Maxwell's equations that are going to be the foundation for what we're going to be seeing in the following chapters. We're going to go into nanoscale optical microscopy, discuss about optical interactions, quantum emitters based on molecules and quantum dots. We're going to go more nanophotonics oriented with photonic crystals before going into the numerical methods that we will use for the computational project. We're going to discuss as well what this specific method we're going to be using, numerical FDTD solutions, that the package you're going to be using for the computational project. And then we're going to start the second part of the semester discussing plasmonics. So we're going to introduce surface plasmons and review electrodynamic concepts for noble metals, extend that to localized surface plasmon resonances into nano objects, discuss the concept of nanoantennas, and then we're going to look at the applications of plasmons for optical sensing and spectroscopies. We compare photonic versus plasmonic waveguides, and then we're going to go into more exotic topics like electron-based spectroscopies, metamaterials, and a quick introduction to nonlinear optics and plasmonics. So you can see on the right hand side here how the assignments are spread out throughout the semester with the midterm and final exams as well. So if you have any question, once again, feel free to email me to this email address. And then now we're gonna deep dive into the first chapter of this course.
Enjoy!